Now we'll look at solving logarithmic equations. So using the definition of a logarithm to solve logarithmic equations for any algebraic expression s and real numbers b and c, where b is greater than 0 and b is not equal to 1, log base b of s equals c only if and only if b to the c equals s. You can rewrite it. One way also of express this, like if you have, log base b of s equals c, if you make both sides powers of this base, it essentially has that same effect, that this part cancels and you get s equals b to the c. So, and there might be someone who gets into the comments and says, oh, that's not exactly right. But anyway, that's the effect of what's happening. So for this one, solve 2 natural log of x. Started writing before I even started talking. Plus 3 equals 7. Subtract the 3 from both sides. So 2 natural log of x equals 4. We can divide by 2. So natural log of x equals 2. And then if we rewrite it, this means log base e of x is 2. That means e to the 2 is x. Or you can say, make both sides powers of, and do this another step. Natural log of x, e to that, equals e to the 2. Cancels, so x equals e squared. Or we just go with rewriting what it means, which means this base of natural log, which is e to that power, is equal to x. Let's try the next one. We will divide both sides by 2. So we have the natural log of, and this is x times 6x. I want to be clear on what it's saying. So I think this is a typo. Let me fix that typo. It's just supposed to be natural log of 6x. I'm sorry. So correct your notes. So it's 2 natural log of 6x equals 7. We divide both sides by 2, and we get natural log of 6x equals 7 halves. So what rewriting this would mean that this is the result of e to that power. So 6x is e to the 7 halves. And then you can divide by 6. So x equals e to the 7 halves divided by 6. Okay. And as math people, we like that answer. I know that engineers might like that answer as a decimal, and this next one, we have natural log of x equals 3, which seems a little anticlimactic. Oh, this is what they want us to graph it. That's right. So, it's just solving this. It's going to be like I did before. This is a base e, so x is e to the 3. Or you can graph it and see where they cross. So natural log of x looks something like this. And then you graph y equals natural log of x. Y equals 3. And you can see where they cross. And they would cross at x being 20.0855. So put on decimals, put on your graphing calculator, whatever. Okay, how to solve logarithmic equations. Use the rules of logarithms to combine like terms, if necessary, so that the resulting equation has the form log base b of s is log base b of t. Use a one-to-one property to set the arguments, that's like this s and this t, those are the arguments, equal to each other, and then solve that. Solve for the unknown. So these are already in this, just natural log of x squared equals natural log of 2x plus 3. So we already have it in that proper form. So we don't need to do any compressing or condensing or so on. So we can take the x squared and set it equal to the 2x plus 3. So that's x squared minus 2x minus 3 equals 0. So we can factor, it'd be x minus 3 times x plus 1 equals 0. X minus 3 equals 0 means x equals 3. X plus 1 equals 0 means x equals negative 1. So let's just make sure that these both work into the original. So natural log of 3 squared, is that equal to the natural log of 2 times 3 plus 3? That's natural log of 9. Is that equal to the natural log of, that's 6 plus 3 is 9, so that works. So that's for x equals 3. And how about x equals negative 1? So is the natural log of negative 1 squared equal to the natural log of 2 times negative 1 plus 3? So that's the natural log of 1 equal to the natural log of 2 times negative 1 is negative 2 plus 3 is 1. So, and by the way, those are both 0. So yes, they both work. Okay. So these are the solutions to our equation. Okay, and that's it for this video.